There are dire warnings that New South Wales will be hit by increasingly extreme weather.
2015 was the hottest year since climate records began. Your show this July was the single hottest month in recorded history.
Australia sweltered through its hottest spring on record.
Climate change is now affecting every country on every continent.
It's the rate that's of great concern.
And what do you put that rate down to?
Oh, it's human activity.
We have everything we need. Some still doubt that we have the will to act, but I say the will to act is itself a renewable resource.
Hello, I'm Dr Renee Beale, Science Communicator and Curator at the Royal Society of Victoria. I'm delighted to be presenting this climactic special podcast for National Science Week 2019. Today I'm joined by Dr Kate Selway, an earth scientist from Macquarie University in Sydney. Kate, welcome to the podcast.
Thanks so much, Renee.
So I thought we could go right back before the time that Kate Selway was an earth scientist and talk about some of your early experiences with going to school and perhaps maybe discovering a love for science.
I think I've always been fascinated by the world. Probably in science, my first love through school was always physics, much more. I didn't really discover earth science until I got to university. But also, to be honest, when I was at school, I really love a load of different things. I think English was probably my favourite subject at school, and I always loved languages as well. I did Japanese and German through school, and I loved art as well. I still do a lot of sewing and design and all sorts of different things. So I actually found it really challenging when I was getting towards the end of school to decide what it was that I was going to do. And part of my decision was really just being able to continue with all those things that I enjoyed. And I think that, save with my love of English, I can still read books really easily, but it's harder to have a lab in your backyard and do some science as a hobby. So that was part of my reason for continuing on with science. Then when I started university, my plan was to do a physics major, and I loved thinking about how maths controls how our universe works, and I love astronomy, and I love lots of things about physics. And it was really just in first year, actually I just needed an extra subject, and somebody convinced me to do geology, and I didn't expect it to be terribly exciting, to be honest. I just thought it's looking at rocks and how interesting are rocks. And then I discovered that rocks are really, really interesting, actually, and that instead of just looking at boring rocks, we're learning about huge processes going on in the earth, and that even in looking at a rock, it's looking at this amazing story of change, that maybe this rock was deposited as a sediment 500 million years ago, and then it got buried to 20 kilometres in the crust and got heated up, and all the minerals changed and then thrust up in a mountain belt, and then eventually ended up on a riverbank for me to find it somewhere. And learning to read those stories in the rocks, I really, really loved. And then also that it took me outside, it took me out of a lab, and it took me out of in front of a computer screen into the field and being able to see a bunch of amazing places in the world.
So many people wouldn't know this, but I remember from science degree that actually earth science has a lot of physics in it. Actually, surprisingly.
Yeah, exactly. And I think one of the great things about earth science is the earth is really, really complex, and there's all these really big processes going on, and most of them are really hidden from us as well. It's a big puzzle, and it's really, really hard to figure out that puzzle. And to answer any of those questions, you actually need a bunch of different strands of science. So I'm a geophysicist, so my background is more in the physics, and I use, I guess, physics to look inside the earth, and I think about how waves passing through the earth interact with different properties of the earth. So there's a lot of physics in that, but then I also need to think a lot about chemistry. So different processes going on the earth, then maybe there's a fluid that's moved through a region, and the chemicals in that fluid have reacted with the rock, and then you end up with a different rock composition, and that will mean that when a seismic wave passes through it, it behaves differently and interacts with that rock differently. So I need to know the geology, but then I need to know the physics as well, and I need to know the chemistry too. And so it's a science that requires a broad knowledge of a lot of different sciences, and the ability to draw all of those strands together and see how they all interrelate. And that's actually one of the things I find really exciting about it. You don't end up locked into a very small niche. To be a good geoscientist, you're always being pushed to expand your understanding more broadly.
And also the universe is kind of your lab, so you're not stuck indoors.
Exactly, yeah. So my research, I'm mainly interested in the Earth's mantle, especially the upper mantle, and the crust as well. So from the surface down to about 400 kilometres depth. And this is the depth in the Earth where we have the tectonic plates, and then beneath that the mantle's flowing and kind of oozing around and convecting and moving those plates around. And I'm interested in how those processes going on in the deeper Earth control what happens at the surface. So control where we have earthquakes and where we have volcanoes, where we have mountain ranges, where we have oceans. And so as part of that, then it kind of means that I need to go to the places in the Earth where the Earth's doing really interesting things. And so my research has taken me all over the world, all 7 continents. I'm yet to do a field survey in Asia, but that's the last continent that I haven't kind of dug a hole and deployed one of my instruments on yet. And then going to the places and experiencing things and going there for the science, but then as part of that, having these incredible life experiences that had I not made that fortuitous decision in first year to pick up geology, I would have never been able to go to those places and experience those things.
So when you were a child, do you remember being particularly excited about being out in nature? Was that something that...
You know, not hugely. So we were, as a family, we weren't a family that went camping. We didn't go hiking. I did not like being outside, but actually my mum will often say when my sister and I were little, and she would be encouraging us to, go out to the park and play, and we would be happier just sitting inside reading books. So I was not a really outdoorsy kid. And that's actually another reason that I'm so glad that I happened to pick up geology, because if it had not been for that, then by myself, I don't think I would have ended up kind of learning and discovering that I actually really love those things. So, yeah, my first camping trips in my life were on my undergraduate field trips, and I was borrowing tents from people and I had no idea what I was doing. But then over time discovered that just how great it is and how much I love it. And so now I get to do those things as my job, but I also do those things for fun as well.
That's awesome. So originally what drew you, well, obviously it was fortuitous that you discovered geology in the first place, but then the research question drew you in, and then, the love of being out in the field came after that almost, or at the same time as that. Yeah,
I think that's true. I found it a really enjoyable subject to study at uni for a bunch of reasons. So I really loved the field trips, but I also loved that doing that meant that I got to know the people I was studying with really well. I wasn't in a huge physics lecture theatre with 400 other people that you're never going to talk to. I was in a class with 30 people, and you're there spending 2 weeks in the bush together and getting to know each other really well, and also getting to know your lecturers really well, and probably partly through that then gain more of an understanding of some of the bigger questions that if I went on in earth science that I could be looking at. So it was those things. It was discovering just how interesting it was and how much we don't know about the earth as well. It's also it really is still a science where huge discoveries are still yet to be made. It's not something where we basically understand what's going on and we're just filling in the details. Even plate tectonics, it's only 50 years ago that people kind of really all agreed that plate tectonics is happening. And that totally underpins everything in geology. And there's still a lot of things, even now, accepting that plate tectonics happens, but there are still a lot of things that we don't understand about, what's actually going on in the earth that allows that to happen. There's always an astonishing statistic to me that the centre of the earth is a bit over 6,300 kilometres away. And the deepest hole we've ever drilled is only 12 kilometres. So it's just this tiny pinprick at the surface of the earth that we've actually looked at. And everything else, we just have to use our imagery, kind of like taking x-rays of the earth, putting out sensors on the surface and looking into the inside to get the best idea that we possibly can of what could be down there. And it's really, really hard because it's huge and there's not many ways that we can see inside it. That got me really excited as well, that these are big questions still to be answered, And it just kind of blew me away that we didn't know a bunch of this stuff, you know.
Well, it is quite interesting, isn't it? Because we've sent things into the sky and into space a lot further than that distance, really.
Exactly, yeah. In many ways, we know more about what's going on in outer space than we do beneath our feet in our own planet. So that's really exciting, and that those processes affect so much of what goes on the surface, both in terms of the development of the planet going from, initially the Earth was a ball of molten rock, to go from that to now this planet where we have trees and oceans and air that we can breathe. And it's these processes going on in the Earth that control that. For me also, to be honest, as a university student, the fact that there was the prospect of jobs in earth science was a factor as well. It turned out then when I finished university, there weren't any jobs. And I think since I finished, I finished my undergrad in the early 2000s. And at that time, most of the jobs were in the mining and oil industries, at least I'm from Adelaide, at least in South Australia. But since then, it's kind of expanded and there's a lot more jobs in the environmental sector as well. And so that's great as well. So then I think a lot of different options for people. For me, I love going outside and I love the fieldwork aspect, but there's lots of people who don't enjoy that, and there are lots of jobs that don't involve any of that as well.
Excellent. So let's come around to you now in terms of some of your recent projects and what you're trying to, the places that you're going at the moment on your camping trips, and also what you're trying to discover about the things that we don't know, the known unknowns, if you like, of our own planet.
The most recent project that I'm working on, that I've just come back from the field about a month ago, is working in Greenland. And this is a big project that's actually funded by the Norwegian Research Council. I lived and worked in Oslo for a while and still have colleagues over there. So this is a project that fundamentally its goal is to improve our estimates of how much ice is being lost from the Greenland ice sheet. And we actually need to understand what's going on in the deep earth to be able to do that. And that's because the ice sheets are a big weight sitting on the surface of the earth. And when they melt, that weight is released and the earth rebounds beneath them. Kind of like if you've got a person sitting on a memory foam mattress and they stand up, and then gradually that mattress will rebound. And so the earth does the same way, and in the same way it's gradual. It doesn't happen immediately. And so we don't actually know how quickly the Earth is rebounding beneath Greenland and Antarctica. And so that's what our project is doing, to take some measurements to, at least in Greenland, to figure that out. And that's important because we estimate or calculate how much ice is being lost from those ice sheets by using satellite measurements of the elevation of the ice sheet and gravity measurements of the mass there. So as the ice melts, then the elevation goes down and the mass decreases. But tied up in those measurements is this signal from the Earth rebounding. So you've got the ice sheet elevation going down, but then the Earth coming up underneath. And it's a much smaller signal than the ice, but it's still a signal that's in there, and we don't know how big it is, and so we don't know how much it's affecting our ice loss calculations. So that's the goal of our project. We just spent a month on the ice, sort of close to the centre of the Greenland ice sheet, deploying a bunch of our instruments and making measurements that will eventually tell us how quickly the Earth is rebounding. And this is a big project. We'll be going back certainly next year, and if we can stretch our money enough, the year after as well, because that rate of rebound is likely to change across Greenland as well. So we want to get a big array of measurements so we can see how that rate changes.
Yeah, fantastic. So you had been and studied in Antarctic and also Greenland prior to this project as well, haven't you?
Yeah, I've spent a couple of seasons in Antarctica, and I've also done a lot of work in East Africa and in Australia as well. All of those projects were more just looking at geological structures. So I guess had more just straight out academic questions. So East Africa is a good example. So in East Africa, fascinating. People may have heard of the East Africa Rift, where essentially there's a big plume in the earth beneath East Africa, and it's tearing the continent apart. Eventually, East Africa will rift apart and be a separate continent from the rest of Africa. And this kind of process has happened throughout Earth history, but East Africa is the best place to be seeing it happening right now. And there are lots of really interesting questions there, but the question that really got me the most interested is that we can see this rift and we can see part of the continent starting to tear away. But some parts of the continent seem to be stronger and are not rifting, and some parts seem to be weaker and they are rifting. And I was interested in what's the difference, what makes some parts weaker and some parts stronger. Spent 5 years working in East Africa with that kind of goal to answer that question. And I think it's really interesting now. I guess 10, 20 years ago, nobody would have thought about how important it was to know how quickly the Earth's uplifting beneath Greenland and Antarctica. But the results that we've got out of that more academic work in East Africa, that we now know how to take these measurements and how to understand how strong the Earth is, which will determine how quickly it's rebounding. So we've done all of this work that we can now take to Greenland and apply in this situation where now, sort of quite urgently, we need to be able to answer these really big questions about the Earth that are quite esoteric questions. How, the structure of things hundreds of kilometres beneath our feet, but they end up in ways that we couldn't have necessarily predicted, becoming really, really urgently important for humanity.
In the time that you've been there, are you noticing noticeable differences?
I mean, Greenland, so I was there just last year and this year, so it hasn't been a long enough time to see those differences, but I actually was there this year when they had sort of the warmest day, the earliest in the season that they ever have. So I arrived in late May, which is just kind of the beginning of their summer, and it was like minus 25 degrees. It was really, really cold. And within a couple of weeks, and really cold, but the kind of temperatures that would be expected. So maybe by the height of summer, it would be expected to be maybe minus 10 degrees. And within a couple of weeks, it had warmed up. And one day we were actually away from station deploying one of our instruments, commenting to each other that it seemed quite warm. And actually the snow scooters that we were driving, we had to stop because the plastic on the front of the snow scooter started to melt. And when we got back to camp, saw that the temperature, it was only just above zero, but it got to 0.4 degrees, which has, in all of the years that people have been making temperature measurements there, it's never been above zero that early in the season. And it was just an extreme melt event. You're in the middle of an ice sheet. You're hundreds of kilometres from the coast, and really, really bizarre to feel the surface of the snow start to get a bit soft and melty. It was really extraordinary. And a lot of the people I was there with had been there in 2012, which was a famous melt year, when at this camp, as I say, in the middle of the ice sheet, there was a rainbow in the sky because it was raining. I mean, it shouldn't happen. So that was extraordinary to be there for that. And now just in this last week, now Greenland's had the biggest melt event in a day that it's ever had. So I personally haven't been there enough years to see it, but just looking back at the records, I can see that these times that I'm there are extremely unusual. And you can see you fly, in Greenland at least, to get to these research camps that are in the centre of the ice sheet. Actually, the US Air Force National Guard do training flights. So you get there, you're kind of in this big, beefy US military plane, and you get strapped in kind of sideways in it, and there are tiny little portholes that you can try to get a little look out of. You take off from the coast of Greenland, it's all mountains. And as you fly inland, you fly over the edge of the ice sheet and eventually come to the centre. And it is extraordinary as you're flying, especially over the edge of the ice sheet, just hundreds and hundreds of melt pools that you can see on the surface. And there are kind of this iridescent popsicle blue colour. It seems like a colour that shouldn't exist in nature. There's just hundreds and hundreds and hundreds of them. And the old timers who've been going back for decades and decades say that it's, in the old times, you'd see a couple, but nowhere near these melt events that we're seeing now.
Wow. So just sort of coming full circle, I suppose, with all this research that you're collecting, obviously you're collecting all this data and you know, as you've been speaking, it's obvious why we need to keep these records so that we know that things are changing and things are always evolving and changing, and then using that data to try and understand what what the consequences will be for that, and how the Earth will actually respond to things like losing ice on its surface. What are you hoping are the outcomes of what other researchers or other people might pick up your data and do with that data moving forward?
This season in Greenland was a really enjoyable season for me. The camp that we were at was called East Grip Camp. It's really an ice drilling camp, and I haven't been at an ice drilling camp before. And so most of the scientists there were ice sheet scientists. So people drilling this ice core and people making measurements on the ice core, and also just ice sheet modelers who were trying to predict what's going to happen to the ice sheet and how it's going to evolve with time. It was fascinating for me because I haven't seen that stuff before. I loved learning a lot about the ice sheet science that I didn't know. But also, I think one of the really nice things about camps like that is you have then all these different scientists from different fields all shoved together, living in each other's pockets for a month, talking a lot about science. So places like that where we can really see how our very different fields can relate to each other. So for instance, these questions I was talking about the Earth uplift, they'll feed directly into the ice sheet models. But part of the reason, well actually the main reason that they're drilling at that camp is because the camp sits on an ice stream, essentially a big glacier, that extends, mostly glaciers are just around the edges of ice sheets, but this one extends really far in, almost to the centre, and no one understands why. But ice streams are really important because ice sheets lose ice partly through melting from the surface, but also from glaciers and ice streams flowing out to the sea and then carving and losing things to icebergs. And we can kind of model as temperature rises how much that's going to affect melting, but there's a lot that we don't know about how these ice streams behave, why some places there are ice streams flowing and other places the ice sheet is really frozen solid to the bedrock. It's the first time anybody's ever drilled into an ice stream to understand how the ice is flowing and what are the controls at the base of the ice sheet that mean that it's flowing there. And so from being there, then we realise more and more that part of what we can do is use our images of the deeper Earth to understand how hot the Earth is and how much heat is flowing out of the surface of the Earth and how that might be part of the control on why the ice sheet is flowing so much. So things like that without actually meeting these different scientists and talking to them, that you don't even understand how your science can work together. So it's really exciting to be there, and I think over the next few years as we're doing that more and more, I think we'll see more and more collaborations between our science.
Dr. Kate Selway, thank you for joining us today, and thank you for being one of our special guests for National Science Week 2019.
That's my pleasure. Thanks very much for having me.
Excellent.
Thank you for joining us. You've been listening to Climactic, the flagship podcast of the Climactic Collective, a podcast network dedicated to lifting the voices of the climate community. You can find out more about the people behind Climactic and all the shows we produce at climactic.fm. We are a social enterprise podcast network, and we greatly appreciate your support. You can find a link to our Pozible where you can support us directly in the show notes of this episode or from our website. Thank you for listening, and from the whole Climactic Collective, keep up the great work and take care of each other in these climactic times.
The Climactic Collective.